I'm Daigo.
And I'm Sam, and today we're going to be looking at a problem from comp1521. The question asks to convert a decimal number into 2's complement representation.
Alright, so let's look at this concrete example, -5. So, what the first one we want to do is we want to find the binary representation of 5. So 5 will be equal to 1, 0, 1 in base 2. And for these, you want to use 8 bits. So this will become 0, 0, 0, 0, 0, 1, 0, 1. And this will be completely fine if you wanted to represent 5 into its complement. However, we want to represent -5. So there's a few extra steps. Alright, so the first step would be to invert all the digits in this number. So this number would become 1, 1, 1, 1, 1, 0, 1, 0. And then for the final step, we just add 1. So it will become 1, 1, 1, 1, 1, 0, 1, 1. And this would be the 2's complement representation of -5.
Okay, and to check our answer, we're just going to convert the 2's complement back to decimal and make sure it's what we started with. So first let's write down 2's complement. And the first step is to look at the sign bit. So in this, if the sign bit were 0, that is, it were positive, we could simply read off this number as a positive integer. But because the sign bit is 1, which means it's negative, we have to do a couple extra steps before we do that. So the first step is to flip the bits. That is, change 1s to 0s and vice versa, and then we add +1 to this. And now we read off this binary. We know it's 5 because that's 4 plus 1, and then we add a negative sign because we had a negative at the beginning. And we know that's what we started with, so we know that this representation is correct.